Hi, I'm Stan from Ballistic Systems, and what I'm going to do is demonstrate how to assemble the MD Basic board. This is a board that will allow you to use an optical trigger or a light beam to trigger objects that fall and break the light beam and then trigger a flash for high-speed photography. Now I've gone ahead and I started to pre-assemble this board, and we'll go ahead and go through some of the basic assembly, and then I'll show you what a completed board looks like, and then we'll test it and then give you an idea of how it operates. Okay? So the very first thing I like to do is I like to insert all of the resistors and solder them in place. So that's going to do. I'm going to take some of the resistors and I'm going to put them in place, and I'm going to spread the leads out a little bit so they don't drop out the other side when I turn the board over to solder. Another resistor goes here. Now if you notice on the printed circuit board, there's basically drawings to show you where the parts go, and there's a part number. And the instruction sheet that you'll get with the kit will show you the part number and what part goes in place. So now that I've got all the resistors in place, I'm going to go ahead and solder them in. And what's really nice to have is one of these little handy devices from an electronic supply store. I got mine from Electronic Gold Mine. They're only a couple of bucks, and I bought several of them because, as you see here in a couple of minutes, I use them to hold the IR transmitter and the sensor board so I can pass objects through it and trigger the equipment. Now if you notice, I'm just soldering very quickly. I don't leave the iron in place very long. And you want your solder joints to look like an upside down Hershey Kiss. If it's nice and shiny and looks like a Hershey Kiss, then you have a good solder joint. So I'm going to go ahead and trim the leads off now. So they're nice and flush with the board. The next part I'm going to install are the transistors. And transistors are these little black parts, and they're either going to be marked 2N2222 or 2N3904. Either part will work just fine. And if you'll notice, the part has a round side and a flat side, and the artwork on the printed circuit board has a round side and a flat side. And you want to match the part to the drawing on the printed circuit board. And you're going to push it all the way down. And again, spread the leads a little bit apart so the transistor stays in place as you solder it. Now these parts are spaced pretty close, or the pins are spaced pretty close together. So you're going to need to be careful with your soldering, or you'll end up with a solder bridge. If you get a solder bridge, use the solder wick included with the kit, and then remove the solder bridge. And the instructions on how to use solder wick are also in the instruction sheets. So I've gone ahead and soldered that in. I'm going to look to see if I've got a solder wick, or a solder bridge. I do not, but I do have a solder joint that doesn't look quite right. So I'm going to go ahead and just reapply heat to it. Okay, now it looks like a nice shiny kiss. And I'm going to trim the leads off. And I'm going to take the second transistor and I'm going to put it into position as well. I'm going to spread the leads apart a little bit. And I like to have a little space between the board and the transistor. So I just pull up a little bit on it. I know the part's going to stay in place. And that part got soldered in very nicely. Again, we'll trim the leads. Now we're going to solder in the smaller of the two connectors. We have two connectors, one for the phototransistor or the sensor board here, and this connector is for the flash unit. So we're going to go ahead and put the one designed for the sensor board in next. And again, there's a little drawing here, and you can see the footprint for the pads, and it just goes in here. Now, because this part doesn't have long leads on it, I'll try to spread them, but I don't think I'll be successful. I won't be. I lay it flat on the table, and I apply solder to one of the leads, and then I hold the board and let the solder solidify. Then I check to see if the part is flat on the board and if it's square. And if it needs to be turned a little bit, I can turn it a little bit now, and I've got it nice and square in place. And I'll go ahead and solder the other leads. Okay, now that connector's in place. The next parts I'm going to install are the two electrolytic capacitors, or the capacitors that look like this. Okay? These are polarized. That means they have a positive and negative side. And on one side you'll see the negative markings, and that designates the negative side of the board. Also on the part you'll see the value of the part, and we're going to start off with the 22 microfarad part, which is here. And again, you can see the negative marking, so that's C2, and C2 is on the board right here, and there's a little plus by one of the pads. That's where the positive part goes, or the positive side goes, and of course then the negative would go on the other side. And again, I just go ahead and spread the leads apart. And I'll go ahead and trim the leads. And then we'll go ahead and do C1, again remembering that there's a negative side to the part on this side, and the longer lead of the part, or the longer lead here, goes into the positive side of the diagram. And we'll go ahead and spread the leads apart. The next part I'm going to install is the integrated circuit chip, or the IC chip. This is the heart of the kit. Without this part, the kit will not operate correctly, and it has an orientation to it. You'll notice on this particular part there's a little notch on this side here. That designates that pin 1 is right here. If you don't put pin 1 in the right place, the kit will not work. On the printed circuit board, there's an outline, and you see a little notch in the chip there. It could also be a little dot or a little dimple there as well, and there's a little teeny 1 designating pin 1 on the printed circuit board as well. So you want to make sure pin 1 on the printed circuit board and pin 1 on the chip go together. That way the chip works correctly. And sometimes the leads are spread a little too far apart. You just need to bend them in a little bit, and they'll go in through the holes correctly. So go ahead and solder this up. Now I like to solder from the side when I do an IC chip, and that's because it helps eliminate solder bridges. And I just work my way up the rows of chips, making sure that I get nice, clean solder joints, taking my time so I don't get a solder bridge. And all the joints look like little Hershey Kisses. Okay, and I'm going to go ahead and check my work. And they all look good. So the next part I'm going to install is a switch. Switch goes with S1 right here. And sometimes the pins are not bent apart and they'll drop right out. I've gone ahead and put the switch in place and it wants to stay in position, but sometimes it doesn't, and you just need to bend the lead back a little bit to add a little friction to it. And we're going to bend it a little bit more. And that way it stays nice and snug in the pads. And I'm going to go ahead and solder that in place. Okay, so the switch is now in position. In the kit, there are going to be two little capacitors. They're either going to be yellow or they're going to be blue, and they are not polarized. That means that they can go in any way they'd like to go in, and it won't affect the circuit's operation. And they're going to go over here by the battery connection in C4 and C3 position. So I'm going to go ahead and insert it in, spread the leads apart. Like I said, these parts can be blue or yellow depending on the manufacturer. Okay, and they're good in position. The next part I'm going to install is R4. R4 is a potentiometer, and it has a dial on it that you turn the dial, and this is your timing delay. This is going to give you more or less delay from the time that the beam is broken until the camera is tripped or the flash is tripped. So this is what you use to adjust the timing delay. And it goes into position marked R4. And again, I'm going to go ahead and put it in. And I'm going to spread the leads a little bit. And everything looks good. The next part I'm going to install is the LED. If you look on the printed circuit board, it's again a round circle with a flat side. And the LED is a round circle around the rim with a flat side as well. And as long as you have the flat side on the flat side of the printed circuit board artwork, the LED will work correctly. And this is a red LED. I'm looking for the flat side now. Okay. And when I do that, I'm going to go ahead and I'm going to bend the leads 90 degrees. And I'm going to go ahead and insert them. I'm going to spread the leads again. And you want to bend the LED about 90 degrees, about a ½ inch from the end. And that's going to work just fine. So we'll go ahead and trim the leads again. And I'll go ahead and finish bending it the rest of the way over. Everything looks good. The next part is the SCR. This is a solid state switch. And there's a flat black side with numbers on it. And there's a side with metal on it. Look at the side with the numbers on it, okay? This is the front side. This also has a pin 1. And you want to make sure that pin 1, which is right here on this side, matches pin 1 on the drawing on the printed circuit board. If you don't do that, you put it in backwards, it will not work in the kit. So you want to make sure pin 1 here matches pin 1 on the printed circuit board right here. And we'll go ahead and trim the leads. And the last connector to go in place is the connector used for the flash. It's the larger of the two connectors. It goes right here on the printed circuit board where it says Flash Con. And it just slips right in there and just push it all the way down. And you solder all three leads in place as well. And that's what the basic board looks like, okay? And this is pretty much all assembled except for the battery connector, which goes right here. And there's a plus and a minus side, with the plus side being a red wire and the negative side being a black wire. And they just solder in position and they supply power to the board. So I'm going to set this one aside and have one that's already wired up. And I'm going to show you how this system works. Here we have an MD Basic completely finished, and I'm going to go ahead and plug a strobe in, and it's already on and it's going to flash. And I'm going to go ahead and hook the battery up to it and turn the unit on, and it's going to flash again. Now I'm going to sit here and wait a moment, and it's going to flash about every 30 or 40 seconds, and that's in its auto reset mode. And what that means is if you have nothing on as far as the IR transmitter, or the diode's not aligned correctly, the beam's not aligned correctly, it's going to go through an auto reset mode, which is what it's doing now. But as soon as we connect the IR transmitter to it, the LED comes on, telling me that we have light on the sensor board here, and this is an IR transmitter board providing infrared light. So anytime something goes between these beams, the camera and flash will fire. Okay? It'll take about 30 to 40 seconds for it to reset, and after 30 to 40 seconds, you can then have something pass through the beam again, like a milk drop or ice cubes or whatever your heart desires, and you will get another triggering in the flash. And that's basically how the MD system works. So thank you very much. If you have any other questions, you can find them in the instruction manual that comes with each kit. And I'm Stan Feichel from Ballistic System. Thank you.